Good day all. In this short video, we are going to have a discussion on how to compute quantity of earthwork in case of a road. Here, the questionnaire has given chainages at a regular interval 0, 30, 60, and the respective RLs of the ground are given. And apart from this, the formation level at starting chainage, that is chainage 0, is given. It is 530. Now, and also here the road surface has a rising gradient 1 in 100. The side slopes also given 2:1 for embankment and 1.5:1 for cutting. Now what we need to do is compute the quantity of earthwork for the road using mean and mid sectional area methods. The formation width of the road is given, which is 10 meters. So let us proceed now. Before we start, we need to calculate RL of the formation. So RL of formation, in fact, at 0 is given. So it has a rising gradient. The formation has a rising gradient. So if you think about formation level at 30 chainage, so what we have to do now? Formation level at chainage 0 is given 530 plus the rising gradient is given, that is 1 by 100. So 1 by 100. So the distance between now starting station and the next station is obviously 30 meter. So now 530 plus 1 by 100 into 30, 530.3. This is the formation level at China is 30. When it comes to China is 60, that is third station, it is 530 plus 0.6. So when it comes to 90, 530 plus 0.9. So that is the true meaning of this rising gradient 1 in 100. Now let's proceed now. So this is the longitudinal section of the road. So here one can say now the ground level and we have formation level. So it is interesting to see this. We have both cutting and filling for this road surface. Cutting is there up to almost near to China's 210, close to 210, not exactly 210, and the filling portion is there uh, after and close to 210 Chinese filling portion also there. In fact, this height is we use it to arrive this height by deducting RL of formation level minus RL of ground level. If you are getting negative value, then it is called cutting. If you are getting positive value, then it is called filling. So this is a typical drawing of longitudinal section with the scale of road. Same thing we presented in Excel, Microsoft Excel. So this is the ground level. As we already discussed at China start 210, it's now changing from cutting to filling. This is regarding formation level with rising gradient 1 in 100. Now let us discuss now how to compute quantity of earthwork using mid-sectional area method. In fact, what is input here is formation width, that is 10 meter, side slope for filling, which is given horizontal 1 vertical, side slope for cutting S2. So filling is S1, 1.5 horizontal is to 1 vertical. Common regular interval is given, that is 30 meter distance between two Chinese stations. So here you see we are preparing a table of station right from 1, 2, 3, 4, 5, 6, 7, and one more station is there which is visible for us, that is passing from cutting to banking, filling. So 8, 9. In fact, we have 9 stations, but one more station in mid, that is passing station. So let us see now. We are calculating height, as you know, RL of formation level minus cutting level, ground level. So that 530 minus 535, it gives minus 5. As we know, it is cutting. So that's why we are writing this value in cutting. Now we have depth now. This is regarding 0 station. When it comes to 30 Chinese, we have 534 ground level, 530.3. As we discussed already, this formation level having rising gradient of 530.3. The next one is 530.6. After deducting 530.3 3 minus 534 RL of ground level will get minus value that indicates cutting. Whereas here you see at China is 210, China is 210. What we can see here at China is 210. So ground level is 532, formation level is 532.1. Now I am getting positive value 532.10 minus 532. So because depth is equal to RL of formation level minus RL of ground level. This is what we are repeatedly speaking. Now we are getting 0.1 with positive value. This we have to enter in filling. This we have to enter in filling. So now it comes to, when it comes to this section, so we have central portion, that is BD, and we have sides also. That is, I can tell you half SD square, half SD square. Together we say SD square. Now when it comes to mean sectional area, here you see we have DM. So I will get the DM. It's taking average of this first station and second station depths, will get mean depth. So hereafter you see there is no entries in first row because we are calculating DM. So then we are saying goodbye to the first row. Now we are entering into the second row. Similarly, with the average of these two, we will get third row. The average of these three will get fourth row. Like that, you see we are having a values of mean depths. So now multiplying with say width, formation width, B into DM, will get central portion area. Now multiplying DM square with respect to slopes. Here we should understand that we have cutting. So up to 210. So we are entering all these SDM square. In fact, for cutting we are using S2 side slope, S2 DM square. All these entries up to this before passing. Now let's discuss at passing. As we know, the depth is 0. At passing, exact point of passing, depth is 0. So we are calculating DMs. So BDM, that is central portion area, SDM square, that is side portion area. But the fact what we have to understand here is it is good to know at 210 we have to enter the values in the filling, because it is a positive value, depth is positive. So we realized that it is banking, what you call filling. So now we are entering S1 DM square. As we discussed, S1 is the slope of the side slope in filling. So that's why we are segregating S2 DM square, S1 DM square in the area of sides. Now if you sum up, we will get total area BDM plus SDM square. So we are writing in cutting up to 210. We are writing after 210. We are writing entering values in filling portion. Now we all know the length, that is 30 meter between two chain edges. So length. Now area into length, that gives the volume. So now here also same, we are maintaining two columns here, one for cutting, one for filling. This is the way we use it to calculate. But what we are trying to emphasize in midsection method, in midsection we use it to calculate mid, that average of the two heights, two depths. So this is the way we are saying goodbye to first row. We are entering into the second row. This scenario till goes. So, but when it comes to changing point, shifting point, we have to have an idea that here it is 0. So then we have to do 2.2 plus 0 by 2, that is 1.1. So this is the last entry in cutting. When it comes to filling, let us see now we have 0. So now in filling we have 0.05. So why it is 0.05? Because 0 plus 0.1 by 2, it is 0.05. So now we are entering this in filling. Similarly, the last row, that is last chainage, we have two values here. How to calculate mean here? 0.1 plus 0.9 by 2. So now we have done unbiased calculation. We have taken care about the changing point. We have duly given weightage to cutting and banking. And one more point is when it comes to when this point 0, when the section, when the line is passing 0, so we have to consider, we have to be very careful in writing the lengths, because here it is crossing at 27. when it comes to cutting portion. Whereas in filling portion, only hardly 3 is there. This we can get from the similar triangles or from the drawing the longitudinal sections um, to the scale. We can arrive these values 27 and 3. See carefully. Here it is not 30 because 0 is there enough. It is passing from cutting to filling. So here 27 is there in the towards cutting portion. 3 is there in the filling portion. So this is the way we will calculate quantities. Now we can see the total quantity of earthwork in cutting and total quantity of earthwork in filling. This is the way we use it to compute. When it comes to mean sectional area method, this is very interesting where we think about AM, not the DM, A1 plus A2 by 2 for the respect to consecutive sections. The same way we will prepare the table. Just here you see we have stations right from 1 to 9, but we have one more station that we have spoken already, we have discussed already, that is between 7 to 8 where 0 is coming, where depth is 0, where the section is passing from cutting to bank. So anyhow, here we are not calculating mid depth. So here we are calculating mid area. So once again, I'm telling you. So we have areas here. We have areas. So the mid we are calculating A1 plus A2 by 2. But understand that up to this cutting portion is there. But beyond that, we have filling portion. Banking is there. Finally, we are multiplying with the length of the sections. That means length between two consecutive sections, that is 30 meter. But always understand that there is a thing we have to discuss here, that is 0 if it is not passing exactly at the cutting portion or filling portion, it may be some intermediate or some other station between cutting and filling, then we have to take care. So we need to consider the distance. Just here is 25 meter and 5, it's not 30. So the section may not always cross the uh, correct what I say chain edge point. It may cross between chain edges. That we have to take care regarding transferring from uh, cutting to filling, or in the vice versa, filling to cutting. Finally, we are getting quantity of earthworks after summing up these columns in cutting and as well as in fitting, in filling. Thank you all.